So welcome everyone to the day 2 of inaugural tinyML Asia Technical Forum. I'm Sakya Dasgupta, CEO and founder of Edge Cortex, and I'll be chairing today's session. It's a great pleasure to talking to all of you from Tokyo here. So the next speaker is Mark Chen from Himax Technologies, and he's going to talk about ultra low power, always on smart sensing solution for tinyML ecosystem. Over to you, Mark.
Hello, everyone. Hello, everyone. This is Mark Chen from Himax. Today, I want to introduce our ultra-low power, always-on smart sensing solution for tinyML ecosystem. There are more and more always-on sensing applications need always watching, always listening, and always monitoring at the very edge devices to keep privacy, low latency, and low power consumption. However, there are 3 major challenges for developers. The first is low energy consumption, because most of these edge devices are powered by battery and need more than several months battery life. The second one is real-time performance. That means low latency and the need to be achieved by high computing performance. The third one is model deployment. Himax provides hardware, software, and a common AI framework to help developers to overcome these challenges. In hardware side, we provide ultra-low power always-on image sensor and ultra-low power AI processor to reduce power consumption, but still keep high performance when needed. In software side, we work with our DSP partner, Synopsys, to provide open source machine learning inference library to optimize NN inference performance. We collaborate with Tensorflow Lite team closely to make Tensorflow Lite for microcontrollers as our building AI framework to make NN model deployment easier and faster. Let me show you how our solution works in following pages. Our ultra-low power AI processor, WE-I Plus, with excellent power performance in always-on vision application, and also support different sensor interfaces to achieve voice recognition with microphone and vibration detection with accelerometer. With unique and patent multi-layer power management and fast wake-up with features. We can capture sensor data and detect the event when CPU is totally shut down. When event is detected, we can wake up CPU instantly and running the inference up to 400 MHz to complete the task as soon as possible, then go back to sleep mode to reduce average power consumption. Security is also one key feature. WE-I Plus can achieve security boot, OTA, TOS with hardware engine to save power and reduce wake-up time as well. To provide total solution for ultra-low power vision application, there are 2 always-on sensors are available with different resolution. The power consumption is only few milliwatts at 30 frames per second. We work closely with Tensorflow Lite team to integrate this open source machine learning framework with our software toolchain seamlessly to make NN model deployment easier and faster. There are retrainable open source examples on GitHub to let developers to build their own prototyping quickly. To optimize NN model inference performance, we applied embarked open source machine learning inference library to link with Tensorflow Lite reference kernel. These APIs can support 2D convolution, depth-wise 2D convolution, and automatic model layer slicing and the data movement. The total inference cycle number can be reduced up to 50% through this software kernel optimization. Here is our development board that can be available online on SparkFun now. In addition to our ultra-low power VGA sensor and AI processor WE-I Plus, there are 2 microphones and a 3-axis accelerometer are built on board as well. All vision, voice, gesture examples can be run on this platform with complete open source toolchain and framework. This page shows average power consumption is less than 2.5 milliwatts, including image sensor and AI processor when running person detection example. This amazing result is benefit from hardware, software, and the toolchain optimization and integration. This demo shows we can retrain person detection model to add bounding box and person tracking functions easily with good accuracy. Thanks for your watching. Please check our website for more information.
Okay, let's see. Or I see that we have a question from Evgeny. So how many I/O pins are typically in the Himax tinyML sensor? And what would be the absolute smallest size of the package that one could have in case of the QVGA type of sensor?
Okay, so in the sensor side, our output pin, because we are very low power consumption, we are not using the MIPI interface. We just using the parallel bus, and they will use the 8-bit parallel bus to connect to our chip. So the total pin number I remember is 24, including all the power and the control pin, I2C control pin. And the major interface is a parallel interface.
Got it. You also mentioned that there is support for Tensorflow lite micro. Do you have any plans of supporting other formats?
You mean the format is that the model format? Actually, we work closely with the Tensorflow Lite for microcontroller teams, and we can convert the butterfly format direct with our machine learning library, connect to the machine learning library, and automatically. So now we support the Tensorflow Lite for microcontroller format only in the current stage. But we also work with other vendor to develop the TBM for the flow in the future. Yes.
Excellent. Thanks a lot, Mark. I would like to thank our sponsors once again, without whom the tinyML Asia Forum would not be possible and be available for free of charge. Starting with ARM, our premier sponsor, the software and hardware foundation for tinyML. Edge Cortex, their dynamic neural accelerator brings near cloud performance to the edge devices. Finally, SynSense. SynSense builds ultra-low power sensing and inference hardware for embedded, mobile, and edge devices. Thanks a lot once again to all our sponsors. I would also like to thank our partners, conference partner SHAI, as well as all our media partners. That brings us to the end of today's session, and I look forward to seeing all of you once again tomorrow for the day 3 of tinyML Asia. Thank you, everyone. Thanks all our speakers and all our sponsors once again. Thank you.